You guys have this written out? So in this example, guys, what we're going to need to do is we're going to need to practice simplifying factorial ratios, right? So like we've just been doing, we're going to have to simplify this, and then we're going to have to solve for n. So that's a little bit different. It's a little bit different than just writing the expression. We have to actually solve for n. So what are the what's the answer or the answers, possible answers for n? So let's go ahead and start simplifying this. So n factorial is actually, looks like this, n times n minus 1, and you keep going down, n minus 2, all the way down to 1. So I'm just going to put a little factorial after the n minus 2. And why would we do that? Because we see that we have a common factor on the top and the bottom. So I stopped at n minus 2 factorial because this is the same as this. And we can just cancel those out. And of course that equals 90. You don't want to forget about that. But what this does is it simplifies this expression, and we can now expand this out. So this would be n times n, right, is n squared. N times negative 1 is minus n equals 90. So you get to this point and you're thinking, boy, I just want to solve for n there. How can I get n all by itself to find out what the answer is? But they're unlike terms, right? So you can't combine them together. You have to leave them separate. So how do we solve that? Well, I don't know if you remember the quadratic equation. We're going to bring the 90 over here, and it's going to look like this. So n squared minus n minus 90 equals 0. So this may be unfamiliar to you. Maybe you don't remember this. But this is called a quadratic equation. Quadratic because we have a variable squared. It's degree 2, and so this means it's a quadratic. When we have two separate n terms like that, we can't get the n by itself. So there's a number of different ways we could do to solve this. We did this in grade 10, and I think you maybe did this in grade 11 as well, depending on what classes you've taken before this. But anyways, so we could factor the quadratic equation, and that might be something that we might want to do. And if you factor the quadratic equation, what you're looking for are two binomials that multiply to this trinomial. And so what we're looking for is two numbers that multiply to negative 90 and have a difference of negative 1, or a sum really of negative 1. So there's 1 between them. So I'm just on the side here, I'm just going to go negative 90. What are the factors of negative 90 that would add up to negative 1? And you might say, hey, 9 times 10 is 90, and if one of those was negative, I bet you we could add up to negative 1. So look at this. If we have a positive 9 and we add a negative 10 to it, we get a negative 1. And of course 9 times negative 10 is negative 90. So those are the two numbers that you're going to use to factor. So this is actually going to be n plus 9. You just go ahead and put this number in there after the n, and this one you put the next number in there after the n. Okay? So that's the first step in solving for n, because we use something called the zero product principle. If this factor times this factor has to equal 0, that means that one of them or both of them must equal 0. Those are the only options. So if this one, n plus 9, if that one equals 0, then n equals negative 9, right? If this one were to equal 0, then n would be equal to 10. So in solving quadratics, you always have, well, not always, but sometimes you have two options. Now, if we were to actually say, oh, the answer could be negative 9, does that present a problem at all? If n is negative 9? Yeah, you may, okay, so think about factorial, right? All of the examples that we've used so far, the number that we start with is a positive number. Okay, we've never used negative numbers. And if you think about a factorial, it's this number minus 1, minus 1, minus 1, minus 1, all the way till we get to positive 1. So really, for factorial, we can only use positive numbers. So n equals negative 9 is rejected because we can only consider, and you might want to make this a little note in your margin, positive numbers, okay, when using factorial, okay? for factorial. Only use positive numbers. So negative 9, can't have it. What about 10? Would 10 work? Well, 10 is a positive number, and so 10 should work. Let's check it. Okay, let's do a little check here. Let's do 10 factorial over 10 minus 2 factorial equals 90. So I'm taking one of the solutions that I got here, and I'm just checking it. So this is going to be, all right, oh, actually I do have the check below here, so let's just skip down to below here. So 10 factorial over 8 factorial. The 8 factorials would be gone. 10 times 9 times 8 factorial over 8 factorial. So 10 times 9 equals 90. That works. And of course we reject the negative 9. Okay, so that's the one way. Now the other way that you might want to, if we're talking about quadratic equations, the other method is the quadratic formula. Do you guys remember the quadratic formula? X equals negative b plus or minus root b squared minus 4ac all over 2a. Right. Annoying song in your head. Good. From years ago. Awesome. So what this means is, I know, you can shiver now. Okay, so this was our quadratic equation, right? N squared minus n minus 90. So a is 1. That's this number right here. B is negative 1. That's this number right here. And C is negative 90. That's the constant. So if you plug those values in to the quadratic formula, you will get the two numbers, the two solutions that we got, negative 9 and positive 10, which looks like this. Okay, so if we, okay, so I'm just going to go ahead and write this down here, negative 1. Oh, is it still frozen? Oh. Okay, so if you don't like the factoring method, which I hope you do because this is going to be a little bit longer, but this will work all the time. It's just a little bit more writing, I guess. But here you go, you end up with the same answers, and then you would reject the negative 9 for the same reasons. Okay? So that's what using the quadratic formula looks like here. Right there. Okay, questions?